Hi, welcome everyone to today's webinar hosted by Swedish Exergy. Today we are going to talk about the topic of wastewater sludge, the current issues that we're seeing, but also our proposed solution to these issues. The presenters today is going to be my colleague Manish Verma, who is our Business Development Manager, and also me, Christopher Lavender, our Sales and Marketing Coordinator. Before we begin, I just want to let you know some good to know things. We have chosen to do this webinar through the YouTube platform, but in order to use the chat functionality to write your questions, you need to sign in to a Google account. However, if you do not have a Google account available, you can always ask and send questions to my email on display on the screen right now, either during the webinar and also after the webinar, and we will answer them accordingly. We've also noticed that some of you attendees are in the industry for biomass and animal feed, and would like to let you know and also everyone else know that we're hosting two other webinars this spring, one for biomass, but also one for animal feed on how our dryers can be used in those types of applications. A lot of time for this webinar is roughly about 30 minutes. And if you're curious to learn more, you can always visit our website at swedishexergy.com. First off, I would like to go through the agenda of today's webinar. We will begin by presenting us as a company, who we are, and our experience with handling sludge. We'll also define what sludge is, talk about the current issues that we're seeing, and also when we talk to companies and municipalities, what they're seeing, current practices with handling sludge, and then Manish is going to talk about our suggested solutions for how we think the best way is to deal with the sludge. First off, who are we and what do we do? We are an engineering company based in Gothenburg in Sweden, Gothenburg being the second largest town in Sweden. We specialize in dryers, especially superheated steam dryers, which we invented in the early 70s, and that's also when our company was founded. We have executed projects worldwide, globally. We have been working on solution for wastewater sludge since the early 90s. We started in the early 90s by conducting testing and studies with our local wastewater treatment plant here in Gothenburg. So we have a good long experience with dealing and handling sludge. We also have a pilot plant where clients can conduct pilot testing with their projects. Like mentioned, we're focusing and specializing in dryers, but we also have our own evaporators that we design and build. So moving on to what's the definition of sludge. Well, our definition is that sludge is any solids, semi-solids, or liquid residue from the wastewater treatment process. So it's basically everything that gets flushed down into the drain. This is also what makes it so hard to define what sludge contains. But some of the things that we know and that we can see that sludge contains is heavy metals like cadmium, copper, lead, and other various types of heavy metals. Prescription drugs. It's common to find traces of antibiotics and other types of prescription drugs in the sludge. And of course, also other types of human waste. Like I said, everything that gets flushed into the drain eventually turns into sludge after the treatment process. But sludge isn't all bad. It contains a lot of good things as well. For example, sludge has a very good energy potential. It also has very high levels of phosphorus. As the population of the Earth is ever increasing, the demand of food is also increasing, which also leads to that demand of phosphorus is also increasing. For an example, here in Europe, when we saw a phosphorus crisis a couple of years ago, we could actually see that the levels of food prices is actually going up. So what are the current issues that both we're seeing and the companies and the municipalities that we're talking to are seeing. One of the main thing is it's incredibly expensive to dispose of sludge. This is due to the high water levels or the high water content of the sludge itself. A lot of municipalities and wastewater treatment plants, they contract other people to come and pick up their sludge at a cost to then be disposed of, either incinerated or spread into farmlands, for example. But to get a perspective, in the European Union alone, we produce about 10 million dry solids tons of sludge per year. So that's 10 million tons of dry sludge per year. But considering that the sludge has a water content of upwards about 95%, you can really realize how much sludge we're actually producing every year. If we look at Germany, for example, which is the biggest producer of sludge in Europe, they produce a little bit over 2 million tons, dry tons per sludge per year. And when talking to both municipalities and companies in Germany, they're seeing that the cost for disposing the sludge is ever increasing. Right now, they have to pay about 100 to 120 euros per ton that they're disposing of the sludge, but they're believing that these figures will rise upwards to about 160 euros per ton of disposed sludge. Like I mentioned, one of the current issues is that we're actually mostly transporting water. Even if the treatment plant has a mechanical dewatering system, which maybe gets the dry solids content to about 30%, it's still roughly, or 70% of what you're transporting or disposing is still water. Another issue, like I mentioned, is the uncertainties of what the sludge contains. I mean, it contains a lot of heavy metals, prescription drugs, and lots of other unknown substances that's hard to recycle and hard to dispose of properly. Then it's also hard for both municipalities and companies to find cost-effective and at the same time environmentally friendly ways to dispose the sludge. It's normal that you either have a cheaper solution that's maybe not that environmentally friendly, or you have a more expensive solution but that is environmentally friendly. We're also seeing more stricter rules and regulations, especially here in the EU and especially here in Sweden. In Sweden, in fact, we have some new proposed stricter rules and regulations that will basically effectively ban the spread of sludge, raw sludge, to farmlands. And this is something that will create huge headaches both for municipalities and companies alike. And we do believe that this is a way forward for the whole world, that globally these rules and regulations will be stricter in the years to come. So we believe that the companies and municipalities has to act now before it's too late. So what we're seeing, and also when we're talking to all these companies and municipalities, the current practices today, the most common one that we see is that we're spreading the sludge to farmlands. And we can all agree upon that the sludge is a good fertilizer, but it also has a backside. It has all these heavy metals, all the prescription drugs, and all the other substances that affect the soil, the crops, the animals, and in the end, the humans. A study that I read a couple of weeks ago actually could show trace amounts of heavy metals in milk from cows that have been eating crops farmed on farmland that has been fertilized with sewage sludge, so that the cycle kind of continues. Other practices is also incineration of wet sludge, or let's say sludge that has been mechanically dewatered at the treatment plant to about 30% dry solids. This generates a very low boiler efficiency, since normally you can't just incinerate the sludge by itself. You normally have to pump in lots of natural gas to be able to incinerate the wetter sludge. This leads to a higher cost and also higher levels of emissions. Then we're seeing drying properly and incineration, which is something that we believe is the way of moving forward, and we're very happy to see this. But the types of dryers that's being used right now is very polluted. They're very energy intensive and maybe not the best suited types of dryer for drying, especially sludge. The last practice that we see, maybe not so much in European Union, but in other parts of the world, is just pushing the problem forward and just disposing it in the landfills. Throughout the years, when we have been talking to both municipalities and companies, we have been gathering all of their wishes on how they would like the sludge treatment to work. And throughout the years, we've been piling these up into this document or this slide that you're seeing right in front of you, which we are calling the sludge treatment wish list, which is something Manish now is going to go through and also talk about our proposed solution for the sludge handling.
Thank you, Christopher. So, I'm going to go through a couple of propositions that we have and how we see it and how we solve sludge. Well, the first one, as we were doing already, as Christopher mentioned, is combustion. Now, this can be done in monocombustion. This can be done in existing combustion units that we have in different cities. The same way of doing it is we take the wet sludge at about 25% dry solid, and we achieve this by decanter or centrifuge, as an example. That sludge goes into the super steam dryer and gets dried to 90% dry solids under 15 seconds. That sludge then goes into a combustion unit where we recover the phosphor from the ash after combustion, and we produce the energy from the combustion. And this phosphor can then be used on farmlands, and we achieve a circular economy. Now, this energy that we're getting back from the dryer in form of condensate and heat, this energy can be used in other processes, such as digesters, increasing the production of biogas, as an example. So this is an energy that is recovered from the dryer and at plant's disposal. Now, the second one where we look at is if we take this sludge and we dry it and create biocoal through pyrolysis. Same solution as before. We take the wet sludge at 25% dry solids into the super steam dryer and we get our 90% dry solids. Now, these figures, 25 and 90%, this can be adjusted depending on what we have available. The 25% can be 20%, it can be 30%, it can be 15% into the dryer. And same when it comes out of the dryer. It can be 85%, it can be 90%, it can be 95% if required. Now, this dry sludge then goes into a pyrolysis where we get biocoal with phosphor still in the biocoal. From this pyrolysis, we get the pyrolysis gases into a gas burner. We get the flue gases that drive the pyrolysis, and from the pyrolysis, we get the flue gas into a heat exchanger, which gives the energy to the dryer. And again, from the dryer, the super steam dryer, you're still getting that energy return for other processes. And we clean the flue gases and cadmium. Now, why the super steam dryer? Why are we proposing the steam dryer as compared to any other technology that we have in our arsenal or any other technology that's out there? Well, if we go back to this wish list that we had, is we want to achieve a uniformly dry sludge because we want to have the boil efficiency as efficient as possible, as we don't want any fluctuations. And with the super steam dryer, every single fiber that is in the dryer gets exposed to the same conditions. So every fiber gets dried to the same level. We don't get this variation of the top layer being more dry than the bottom layer, and all those issues that we see perhaps with other technologies. We don't want any VOCs or odor. Now, since the super steam dryer is a closed loop system, we don't have any air emission from the dryer. And since it's a closed loop system, we don't have any odor either. And we also want to achieve Class A biosolids. That's one of the requirements. Well, since the temperature in the dryer is high enough, and we are drying under 15 seconds, but we are exposing it to higher temperature, we do get a completely sterilized product when it comes out of the dryer. And this is something that we have done tests, as Christopher mentioned here in Gothenburg, from the sludge, and we have independent labs have done the test, and we achieve Class A biosolids to the level that we actually go above and beyond what is required from Class A biosolids. And if we can achieve negative to neutral CO2 in the process of handling the sludge, that would be great. And the way we see it is that one of the reasons if we dry it with super steam dryer, we recover the energy, up to 95% of the energy, right? And if we combine this together with, let's say, a CCS system, and we can capture the CO2 from the incineration, then we can be on a good way towards a negative to a neutral CO2 emission. And wastewater treatment plants, their main focus is not handling the sludge. As you know, it's wastewater treatment. So sludge is an afterthought. It's not their core business. So they don't want to spend a lot of time on maintenance. So you want a solution that doesn't not require so much maintenance. And since the super steam dryer has very low rotating parts, means very little service that is required of the dryer. And as I mentioned a couple of times, the energy consumption is very low because the net energy is about roughly 150 kilowatt hour per every ton of water that's evaporated from the dryer. And that is up to 95% of the energy is recovered from the dryer. So you put it 100%, up to 95% of the energy is returned from the dryer. And this energy can be used in district cooling, heating, or other processes. You can use it as a pre-dryer as well. As an example, you can use an MVR to make the dryer completely self-sufficient of energy requirement, because then we will take the energy from the dryer through the MVR and feed it back into the dryer again. And the recovery of nutrients such as phosphorus is very important, as Christopher mentioned. And we do that via the ash or the biocoal process, or we can also recover the nutrients with the reject water as well before it even gets to the stage where it needs dry. And if we have a dry product, then we can have energy production, and we can produce biocoal, which is soil improvement. And sludge all of a sudden is not a waste, it becomes a resource. And our clients also want a safe and continuous operation, since most of the wastewater treatment plants are located within the city vicinities. And within the city or close to city environment, you want a safe and continuous operation. You don't want any stoppages. And from the super steam dryer, since it's a steam that is the drying media within the dryer, we have no fire or explosion risk whatsoever in the dryer. And we built the steam dryer on height, so we don't take a lot of footprint. It's very, very low footprint that we require. There are other wish list points that we don't have here either that we would like to go through in a different conversation one-to-one, so we look forward to hearing from you on that. I'll pass it back to Christopher.
Yeah, so I just want to talk a little bit about a recent project that we are currently executing in Turkey for one of the bigger energy producers located in Turkey. They have seen, such as many others, the increase in sludge, but they're also seeing the energy potential that's hidden in the sludge. There are today an energy company that burns biomass or incinerated biomass to create both electricity and heat. But what they're now going to do is, with the help of one of our superheated steam dryers, they're going to start accepting sludge from local industries and also municipalities at a cost. They will then take this sludge and dry it in one of our superheated steam dryers from about 80% moisture content down to 25% moisture content. The capacity of this dryer will be 330 tons of sludge per day, but since they do believe that the demand will increase, this dryer can later on be upgraded to 500 tons per day. What they're really doing is that as of right now, they're burning or they're incinerating biomass to create electricity and heat, like I mentioned. But now they're also going to mix in co-firing the sludge, which they're getting money for, revenue for. So instead of them having to pay extra for more biomass to produce more heat and electricity, they are actually getting paid by municipalities and companies to take their sludge, So that's basically, well, it's free fuel that they get paid for, that they're able to dry and then incinerate together with the biomass to be able to produce electricity and heat for the local area. So that was the end of today's webinar. We are going to ask some questions that we've seen coming through email. But first, we'd like to thank you for taking some time out of your day and listening to us. This was a very short presentation since we're trying to make it as general as possible. But we would love to have a meeting with any one of you to discuss your application more specific, and we can do a longer presentation and go into more of the details on the benefits and also how the superheated steam dryer actually works and the energy recovery that we can get out of the steam dryer. But like I said, if you have any questions or would like to set up a meeting or anything like that, you can always just email us or call either me or Manish directly, and we are always available at your convenience. Has there been there's been some questions from the email, I believe?
Yeah, there was one. There's a need for retrofitting it. If they have, the question was if they have an existing solution of incineration, drying incineration, can this be replaced with, let's say, a stupid steam dryer?
Yeah, I mean, it's actually very easy for them to implement our dryer or our superheated steam dryer into their existing processes. This is something that we're doing in a lot of our products, not just for sludge, but also for other types of industries. So that's absolutely something we can do. Is there anything you'd like to add to that, Manish?
No, I mean, that's pretty good. I mean, the retrofitting that we do is in other solutions is the same thing. The dryer is already there. The plant already has an existing dryer. And we can then replace that dryer, taking the dryer out, since they already have the energy source. We can replace that dryer with the steam dryer.
Well, looks like we don't have any further questions right now. So we'd like to thank you for participating. And like I said, just contact us if you would like any more information or book a meeting with us. Thank you, and have a good weekend.